Quarter 1, week 6. This is all about radicals. Recall that a rational number can be expressed as a fraction or decimal form. Every terminating decimals and non-terminating repeating decimals are called rational numbers. For example, we have here 1/2. This is in a fraction form. So as what you can notice, our numerator is 1 and our denominator is 2. So this is expressed in a form a over b, where your b or your denominator is not equal to 0. So therefore, 1/2 is a rational number. 0.78. This is an example of a terminating decimal because it stops at the hundreds place. So it's 0.78 or 78 hundredths. So again, 0.78 is an example of a rational number. Next is 0.333 repeating. This is an example of a repeating decimal. Another 0.454545 and so on. So these numbers are called non-terminating and repeating decimals. So these are examples of rational numbers. If we have rational numbers, we have also irrational numbers. From the prefix "ir", meaning it's not rational number. What are irrational numbers? Irrational numbers are the set of real numbers that cannot be expressed in the form of a fraction, a over b, where a and b are integers. The denominator b is not equal to 0, or b is not equal to 0. And also, the decimal expansion of an irrational number is neither terminating nor repeating. For example, this symbol pi. This is an example of an irrational number. Why? Because the value of pi is equal to 3.14159265 and so on. So as what you can notice, this decimal part here, the numbers are not repeated and it will not terminate. So it's non-terminating and non-repeating. So that makes it an irrational number. So we cannot express pi in a form of a fraction. Next is square root of 2. Square root of 2 is an example of an irrational number because square root of 2 has the value equal to approximately 1.414213 and so on. So still, it is non-terminating and non-repeating decimal. Another example is 0.131517218 and so on. Still, it is non-terminating and non-repeating decimal. So this cannot be expressed in a fraction form, a over b. So this makes it irrational number. So these are examples of non-terminating and non-repeating decimals and classified as irrational numbers. Let's now proceed to radicals. Okay, let's identify first what are the parts of a radical. So here we have this symbol is called the radical symbol. Inside the radical symbol is a radicand. And here we have here 3. So this is called the index. And as a whole, this is called radical. Okay, so we have here the square root. What is a square root? A square root of a number is a value that, when multiplied by itself, gives the number. If, for example, we have square root of 16. So this is read as square root of 16. Our radicand here is 16. And we have here, there's no written index. So this is understood that it is, there's 2 here. So this is read as square root of 16. So the square root of 16 is, or the square root of 16 are, we have positive 4 and negative 4. Why is it positive 4 and negative 4? Because when we say square root, we will find a number that when you multiply it to itself, it's equal to 16. So if we have positive 4, if we will multiply positive 4 to itself, that's positive times positive equals positive. And positive 4 times positive 4 is equal to positive 16. That's why positive 4 is one of the roots of square root of 16. And we also have negative 4. Negative 4 times negative 4, that is negative times negative, is still positive. So that's negative 4 times negative 4 equals positive 16. So that's why we have two roots for square root of 16, that's positive 4 and negative 4. Remember that every positive number has two square roots. One is positive and the other one is negative. So for example here, this is read as square root of 16. And it's equal to positive 4 and negative 4. The radicand here is this 16. And the index here, there's no written 2, so it's understood that it is square root. So that's the index is 2 and the roots are positive 4 and negative 4. What is a principal square root? The principal square root is the positive number square root. The principal square root is rational if the radicand is a perfect square. Otherwise, the principal square root is irrational. Let's go back to the given square root of 16. So we have two roots, the positive root, positive 4, and negative 4. Again, how did we come up with positive 4 and negative 4? We will find a number that if we will multiply it to itself, it's equal to positive 16. So that's positive 4 and negative 4. Why? Because positive 4 multiplied by positive 4 is equal to positive 16. And also, negative 4 times negative 4 is still equal to positive 16. But then, which of the two roots is considered as the principal square root? Based on the definition, the principal square root is the positive number square root. So meaning our principal square root is positive 4. Okay, there are examples of perfect squares. Okay, here we have the perfect square. 1 squared is 1, so therefore 1 is a perfect square. Next, 2 squared is 4. So therefore 4 is a perfect square. 3 squared is 9. 4 squared is 16. And 5 squared is 25. How did we get 25? 5 squared means 5 times 5 was 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. And 9 squared, we have 81. 10 squared is 100. So meaning, these are the first 10 perfect squares. Numbers between 1 and 4. So we have 3, we have 2 and 3. These numbers between the perfect squares are called not perfect squares. So they are not perfect squares. Kanang numbers between these perfect squares here. We have here between 4 and 9. We have 5, 6, 7, and 8. So they are not perfect squares. For examples of extracting square roots. For example, if here, square root of 1. Extracting the square roots is just a reverse process of squaring a number. So we have here 1 squared is equal to 1. So therefore, when we get square root of 1, that is equal to positive 1, or we have negative 1. So we have here positive 1. When we multiply positive 1 to itself, it's equal to positive 1. Same as negative 1, we'll multiply it to itself, it's still positive 1. Square root of 4, that is just equal to positive 2 and negative 2. So because positive 2 times positive 2 is equal to positive 4. And negative 2 times negative 2 is equal to positive 4. And then we have square root of 9 still equal to positive 3 and negative 3. And then we have positive 3 times positive 3 is equal to 9. And negative 3 times negative 3 is still equal to positive 9. Next is square root of 16 is equal to positive 4 and negative 4, because positive 4 times positive 4 is equal to positive 16, and negative 4 times negative 4 is equal to positive 16. Same as square root of 25, square root of 36, square root of 49, and square root of 64. So we'll find a number that we will when we multiply it itself, it's equal to the radical. Remember that 0 has only one square root, and that is 0. Because when we multiply 0 to itself, it's equal to 0. And another thing that you should remember, that negative numbers do not have real square roots. Their square roots are called imaginary numbers. So if your radicand is a negative number, then the square root is not a real number. So it's imaginary number. Let's take this example 1. What is the principal root of square root of 16? So remember that the principal root is the positive root. So we have here for the solution, square root of 16. Okay, so we'll find a number that when we multiply it to itself, equal to 16. So that is positive 4 and negative 4. So meaning, square root of 16 is either positive 4 or negative 4. Since 4 times 4 equals 16, and negative 4 times negative 4 is still positive 16. But we'll go back to the definition of the principal root, that it is the positive root. Therefore, the principal root of square root of 16 is positive 4. And is positive 4 rational? Yes, it's rational, because it can be expressed in the form of a fraction a over b. So what is the fraction form of 4? It's 4 over 1. So our denominator is 1, so meaning it is not equal to 0. Therefore, it is rational. Example 2. Determine whether the principal root of square root of 5 is rational or irrational. So we have here the solution. Square root of 5. So is 5 a perfect square? Remember that the perfect squares are, we have 1 squared equals 1, then 2 squared is equal to 4, then after that one, 3 squared equals 9. So from 4 to 9. So numbers between 4 and 9, we have 5, 6, 7, and 8 are not perfect squares. So meaning the square root of 5 is just equal to positive square root of 5 and negative square root of 5. The radicand 5 is not a perfect square. Then the principal square root is an irrational number. Okay, remember that if it's not a perfect square, then its principal square root is an irrational number. Example 3. Between which two consecutive integers the square root of 8 lies? So this is now our problem. When we say consecutive integers, so these integers are, okay, we have here the solution. Square root of 8 lies between consecutive perfect squares 2 and 3. Why is it 2 and 3? So we have here 1 squared is equal to 1, 2 squared is equal to 4, 3 squared equals 9. So where is 8? It's in between 4 and 9. So we have here 8 is greater than 4 but less than 9. So extract the square roots. Square root of 4 is equal to 2 and square root of 8 we have here, it's not a perfect square. So square root of 9 is equal to 3. So meaning square root of 8 is between 2 and 3. Therefore, square root of 8 lies between 2 and 3. So these are the two consecutive integers between which square root of 8 lies. Example 4. Square root of 50 lies between what two integers? So we have here the solution. 50 lies between the consecutive perfect squares of 49 and 64. How did we determine that it lies between 49 and 64? So we have here 5 squared is 25, 6 squared equals 36, 7 squared is 49, and 8 squared is 64. So meaning it lies between 49 and 64. So we have here 50. Numbers between 49 and 64. So you can find here 50. So lower 49, lower perfect square, and higher perfect square is 64. So we'll get the square root. Square root of 49 is 7. That is less than square root of 50, and square root of 50 is less than square root of 64. So square root of 64 is 8. Therefore, it lies between 7 and 8. So you should keep this in mind that estimating square roots is important. We can approximate square root of a number by looking for two consecutive integers between which the square root lies. So it is very important to know how to find the two consecutive integers between which the square root lies. For example 5. Estimate square root of 5 to the nearest tenths. So how? First is we need to determine the principal root of square root of 5. So square root of 5, it's in between 4 and 9. So it lies between 2 and 3. So meaning square root of 5 is in between 2 and 3. So we'll try numbers, decimal numbers between 2 and 3. So let's start with the middle number. So that's 2.5 squared. 2.5 squared means 2.5 times 2.5. That is equal to 6.25. So observe that 6.25 is larger compared to our radicand 5. So we will go lower than 2.5, 2.4. So 2.4 times 2.4, it's 5.76. Still larger compared to 5. We'll go down 2.3 squared. So 2.3 times 2.3, it's 5.29. So still larger than 5. So we'll go lower than 2.3. So 2.2 times 2.2 is 4.84. So we have now 4.84 is lower than 5. Let's now determine which is nearer to 5. So what's the difference? Okay, so we'll try 4.84. So the difference is 0.16. And for this 5.29, it's 0.29. Therefore, 4.84 is nearer to 5. By estimation, square root of 5 is approximately equal to 2.2. Okay, we have another way. We have this formula, the given number minus lower perfect square all over higher perfect square minus lower perfect square. So how to estimate, to get the estimate? The principal root of square root of 5 is between 2 and 3. Remember, we have here 1 squared is 1, 2 squared is 4, 3 squared is 9. So meaning 5 is in between 4 and 9. That is why the principal root is between 2 and 3. So we will identify the values. The given number is 5. And the lower perfect square is 4. And the higher perfect square is 9. We'll substitute. The given number is 5 minus the lower perfect square is 4. And the higher perfect square is 9. Minus the lower perfect square is 4. So we have here 5 minus 4 is 1. 9 minus 4 is 5. We'll divide 1 divided by 5. That is just equal to 0.2. So we have here in the first part of our solution that the principal root of square root of 5 is between 2 and 3. So meaning we have here in between 2 and 3. So 2, this lower number, we will add the decimal number 0.2, so it's approximately 2.2. Example 6. Estimate square root of 40 to the nearest hundreds. So how? The principal root of square root of 40 is between 6 and 7. Why? Because we have here 5 squared is 25. 6 squared is 36. 7 squared is 49. And where is 40? It's in between 36 and 49. So therefore, it lies between 6 and 7. So its principal root is between 6 and 7. So first, we'll identify numbers. Have trial and error. Let's identify numbers between 6 and 7. So I'll try 6.5. So 6.5 times 6.5 is equal to 42.25. Notice that it's bigger to the radicand 40. So we'll go lower. So 6.4 squared is equal to 40.96. So 40.96 is still greater than 40. So go lower. 6.3 squared is 39.69. So it's lower than 40. So meaning it's in between 6.4 and 6.3. So this is still in tens place. Let's have the hundreds place. So what is asked in the problem is the hundreds place. So we'll try numbers between 6.3 and 6.4. So let's take the middle number, 6.35. 6.35 squared is equal to 40.3225. So bigger than 40. Let's try the lesser number, 6.34 squared is equal to 40.196. Still bigger than 40. Let's try another lower number, 6.33 squared. So that is 40.0689. Still bigger than 40. So we'll try 6.32 squared. That is 39.9424. So this time it's lower than 40. This time we will check which is nearer to 40. So we have here this 39.9424 is nearer to 40. So by estimation, square root of 40 is approximately equal to 6.32. That's all, and thank you so much for watching.